Our next presentation, it's Digital Technologies and Future of Buildings by Mr. TOLOUMIS Charis. Please, Mr. TOLOUMIS. Mr. TOLOUMIS is the head of business unit and smart infrastructure buildings for Greece, Siemens SA, responsible for digital and software for business unit smart infrastructure buildings lead country, Italy. You can proceed, Mr. TOLOUMIS.
Hello, ladies and gentlemen, good afternoon. So my name is Charis TOLOUMIS. I'm in Siemens around 14 years. I've been 13 out of these 14. I was in Switzerland in our headquarters for smart infrastructure of Siemens, and last year in Greece. So I'll try to keep the interest high in this presentation, despite the time after lunch and despite the excellent presentation of Mr. Kroll. So what I'm going to talk about basically is what are the trends in the building sector, and I think you will see many similarities to what we saw before. I will start with this slide, which is showing some trends, right? So what is happening now in the world? What are the macro trends? First of all, the most important, climate change. Billions of people are affected from the climate change across the world, from Asia to the United States. Unfortunately, it seems like we are losing the game. So there's no time to step back. There's no time to just move forward. We have to run. And we will see this impact not only in the macroeconomics of our countries, the cost that they have to pay in the next years, but we will see it also in the economics, in the microeconomics, in the economics of our businesses. So this is why it is important also the companies to act responsibly and do something about this, and not expect everything from the government. So the social responsibility is crucial in this battle against the climate change. Another trend we observe is the demographic change. We are getting older. So the number of people above 65 is going to triple until 2050. So this is a challenge itself. And if we see it with another trend, which is the urbanization, which means that mega cities are created across the world, we understand how much we need good infrastructure. Urbanization means that 43 mega cities will be in the world until 2030. Mega city is a city of more than 10 million people. Another trend we see is this word called globalization. What is globalization? Is the combination of the word globalization and localization. We see geopolitical tensions, we see wars, we see pandemics. What this leads to the world is to decrease the number of the free economies, and decrease the number of the free economies by 10%, which is significant. Last but not least, I will mention this word digitalization. Every company is investing 19% every year, more and more, 19% growth in digital technologies and software. Why is that? Because software goes with this speed that the world is changing, and it's there to help us solve some of these problems. And this is why we will see later on how digitalization will play also a crucial role in the buildings of the future. So the future brings some important challenges to us. What happens in the buildings? Why do we all care about buildings? 9.7 billion people in the planet in 2050. We will all live in big cities and buildings. We spend more than 90% of our time in buildings, and the world population is increasing constantly. So buildings are a key core of the infrastructure of our lives, It's about the energy consumption, but not only energy consumption, it's about how we make the cities people-centric and to have comfort and well-being in the buildings. And of course, the energy transition depends on the buildings. We saw it several times today that the buildings consume 40% of the energy consumption globally, and the same for the emissions. 3 out of 4 buildings are energy inefficient, and the buildings that we see today in our cities are going to be there until 2050. 94% of these buildings will be there, which means we have to do something about these buildings. It's not only about the new buildings which will be constructed. So the global building floor is going to double, and the temperature, as we saw also before, is rising, which brings us another challenge about the additional needs for cooling. So all these come together with our regulations, which we see that people start feeling the need to change, start seeing the results of these actions, and we put ourselves targets. We have the Paris Agreement, we have the EPBD in Europe, the Green Deal, in the United States, the bill for the reduction of inflation. Some people say, how do you reduce the inflation if you put money into this? Yes, you can, because you avoid the cost, right? Avoid the cost of later of not doing something about this. So it is important to invest in these technologies, and it is important that there are regulations. But as I said before, it is a matter also of our own responsibility to understand that we have to act ourselves, and that this is important. Now, let's look at what is happening in the building, in the commercial building stock floor area. We said that it is going to be there until 2050, and it's going to double. The existing buildings are going to be there, and the new buildings are coming. If we divide the buildings and get a simplified picture, right? Let's say we have a big building, which is a building above 10,000 square meters, and a small building, which is less than 10,000 square meters. So we have these 4 quadrants here. On the big buildings, most of these big buildings, I would say, they are automated. Right? There is some kind of control in the HVAC, which is good. On the other hand, when we see smart services, when we see this quadrant for smart services, we see that many times people omit to do something in this, saying, okay, why to pay for energy efficiency, for detection, diagnostics, optimization? Why should I spend more money? The question is why. It's not about spending money, it's how fast we will have the payback in this investment. This is the right question to do that. How much I can save versus how much I spend on this. So we have to look at this, quadrant there, and do something about this. The situation is even worse when we see the small buildings, what I call small buildings, which is less than 10,000 square meters. In this case, there is no automation at all. And of course, there is no kind of energy services or smart services to make this building optimized. So this is the situation, and if we see that 94% of the buildings globally, commercial buildings globally, are in this small category, and only 6% of the big one, we understand how much potential we have to do something about the problem of the 40% energy consumption in the buildings. So if we try to automate with simple solutions, these small buildings, and do some energy services or some remote diagnostics where the software can help us achieve automation and energy efficiency, and at the same time, all the big buildings are getting into these smart services, then we have a powerful tool in our hands to exploit and achieve 30 to 60% energy savings, which is important to do something in this direction. So to sum up these key takeaways from this introduction, I would say, of course, regulations and compliance. All big companies are taking responsibility. The company I represent also has a target until 2030 to become carbon zero in terms of operations. All big companies, the real estate companies, are investing on this because they feel the pressure from tenants and from the investors. There are the regulations coming from institutional regulation, from European Union, from the states to do something about this because they understand how much is the cost if we don't. And we have to do then something about retrofitting, a way for retrofitting this existing building stock. 75%, as we said, of the buildings are inefficient. Facility managers is a complicated profession which is tending to need more and more technology to do their job right. And this is also a reason because 3 out of 4 of the facility managers are getting retired in the next decade. And the new generations are having hurdles to accept to do such a job without tools and without software. So we have to help in this direction. And also in this era, the digital era, there is no progress if we do not have alliances and collaboration. So none of the companies, including the company I represent, can do things alone. So we need to play together and let's say, fill each other's shoes in some cases in order to have excellence and to achieve results. When you talk to CEOs and the big companies, 75% of them say digitalization is key and it is a very important driver for the future. But digitalization is not the target, it's not the purpose. What digitalization will bring to us, why I said at the beginning they invest 90% every year more and more into the digital technologies and software. The purpose is to achieve those 3 things, which do not change. They are not new. We want to achieve sustainability, yes, faster than any time before. Energy savings, we want to have our buildings performing, to be comfortable and to have well-being and to have assets which are efficient. And of course, people in the buildings not to get sick, not and to increase the healthiness and the comfort. So these things are there. Digitalization just brings us the means to achieve them faster and more efficiently. The key trends, and we saw it also in previous presentation, is that the IT and the OT are converging. IT meaning internet technologies, networks, connectivity to the cloud, to softwares and cloud services. And OT is HVAC, it is lighting, it is devices, sensors, where the assets, chillers, boilers, all the assets we have in the building. All these technologies are converging, meaning that now they become one thing. And how they are becoming one thing is by utilizing technologies like the Internet of Things, edge, cloud, and digital. So let's quickly see what those things are and how they play a pivotal role in the buildings. Internet of Things, meaning all the devices that we are used to have, meters, sensors, now are native internet devices, meaning they talk directly, they send data to the internet, they talk IP, and they are able to be controlled also from the internet. Before we go then to the cloud though, we have this important layer called edge. Do we all understand what edge means and how important this is still in our world? An example of edge is the phones, the mobile phones we have all in our pockets. This is an edge device. A self-driving car, it's an edge device. The same we have in buildings. We have edge devices which are doing all the computation and all the analysis of how a building should run. A building management system today is running on edge devices. These edge devices now communicate to the cloud, to the internet, sending all the data outside, and also receiving from the cloud, from the internet, control signals. And also signals in order to update firmware, so you don't have to go on a building regularly for cybersecurity patches, you have updates of the firmware and so on. You can all do now from the cloud. So cloud is the third layer, which is very important because it is the future. Sooner or later, everything will happen in the cloud. Also, building management systems gradually will become more into cloud. Nevertheless, we need both at this point of time. Edge is really important because the amount of data is significant and the processing is significant to happen there. Sometimes we deploy algorithms through AI in the edge, but cloud also gives us all this gross data from multiple buildings around the world that you can compare with each other. You can see benchmark, you can run additional analytics, additional AI algorithms, and then deploy the algorithms you want to set for the control and optimization in the edge. So all this should come together at the end. Right? Internet of Things, the devices, the measuring and sending the data, where the computation needs to happen, and the amount of data analysis that has had to happen in the cloud. How we can bring all these things together? Imagine a platform where it brings these three layers together, only to enable us to do these use cases I said before, to achieve more energy and efficient buildings and sustainable buildings, to optimize maintenance and operations, increase productivity, increase the the space efficiency, the health and well-being, and security and safety in the buildings. And to do this, what we would imagine and propose is a platform where all these devices, the IoT devices, all the sensors and meters send the data to a platform which is open. What means open? It means that we should forget property networks, we should forget lock-ins. In this time, as I said before, we have to collaborate. And this means that the APIs, all the data need to be available in the APIs to any user that the client wants to give the data. This platform also should be able to run analytics, to fill the gaps, to understand what is the problem in the data, and to be able to run all these microservices needed architecturally to have a modern platform and data analytics. And then if we have this connectivity, all the IoT and edge devices in a platform where you analyze all this data, then you can unlock the power of the software and the applications that you can flexibly create. Applications that track the energy consumption, when it happens, at what place in the building, what time, anomaly detection to understand if it is normal or not, propose to you with fault detection diagnostics what you can do to improve the energy consumption, applications that track the scope of emissions, 1, 2, 3, make a carbon footprint pathway for net zero for you, benchmark, create comfort score, understand where we can improve in terms of temperature, humidity in our rooms, measure noise, measure lighting levels, and increase the comfort. And imagine the following, imagine an application that can use and deploy AI algorithms in this data and optimize the automation. So not only to do to have a specific set point, for example, for this room to operate, but to find the optimum temperature so that we have an energy efficient building, but at the same time the best comfort. So best comfort and best energy consumption. And this cannot be done with just some levels or some traditional ways of controlling the building. So there are ways to do this, and there are these technologies out there already. Last but not least, the digital twin. We've had it also before, and here we are saying, okay, in 2000 we had only these 2D plans. This means, of course, we had 2D plans before, but at this time we started digitizing the information. In 2010, we just were seeing more of these 3D models. 15, we started doing the process. Understand how important is the process in this construction business, and understand how much we can save if we have digital twins. And now the digital twin is becoming more of a life cycle twin. So what is the difference now is that we can very easily create these 3D models Even with LiDAR, was the way to do it some time before. At the moment, you can even create a very fast model of a building just scanning with your mobile phone. And like this, you can create a light version of your digital twin for a building. And of course, there are other technologies to have complete BIM and all the building information you need, where then you can run simulations. Imagine how powerful it can be having a software which understands the physics of the building, can do a simulation, and then you have the power of data to compare these two. So data-driven modeling versus physics-based modeling. And this is what we see that is going to change a lot in the next years. All new buildings will be BIM-based, all will be simulated, and you can find the optimum scenario, how to run these buildings. Because don't forget, 80% of the energy consumption of a building and the cost of the building is in this operations phase. So only 20% of the cost is in the construction and demolition. So this is why having a building twin or a digital twin can give us these three value propositions. Right? A common data environment, all the data from the buildings, blueprints, and all the data in one place, the as-built designs, etc. Data integration platform, a building management system, a security system integrated in this platform, so you can use one single point of truth, and then the simulation of the life cycle twin, which can unlock us the optimization. So this is the powerful thing about digital twins. And with this, I close, and I hope I'm in time, and happy to see if you have any questions.